Hi all, this is Mr. Yeager for chemistry. This is a short lesson going over the flame test lab a little bit of why, again, what we saw with the different color flames, but more importantly, kind of looking at the idea of why did we see the different colored lights in relation to the movement of the electrons and energy levels. Again, this presentation, this PowerPoint was created by another excellent chemistry teacher, and again, I'm just using it to make the video. Here we go. So, we obviously use light to illustrate that there must be something changing within the atom. And based on the understanding that light is energy, and so different colored lights have different amounts of energies, we're able to determine that the electrons must be in particular energy levels. So with the Bohr model, again, is a very good model showing electrons in energy levels in the different orbits around it. But in the more common quantum model, we don't necessarily know for sure where those electrons are. Like the Bohr models has them very much set, and that's where they have to be. While the quantum model allows them to kind of be in different places within that energy level, but also possibly move up or back down between energy levels. Okay, so that's what we're looking at that point. Okay, so with this, again, how does light relate to atoms? Electrons will absorb energy and move from what we call the lower or ground state that it's in. That's where the ground state is where all the electrons are in their lowest energy state. That's kind of would be considered what would be the Bohr model more. And when they absorb this energy, they can jump to a higher energy level, and that would be called now that the atom, not just the electron, is in an excited state. And the reason for that is it obviously has more energy in it now because the electrons are not all where they originally are in their lowest ground state, but now are in a state of, I don't want to call it even more motion, but like it says, this kind of shaking state of, do we want to hold on to this, or do we go to the next statement and release that energy? Okay, and it's here again and again and again that we really try to make a point. It's when the electrons release that energy, when they go back to a lower energy level, that light is released in terms of what we see with it. All right, we do not see anything happening when the electrons are absorbing energy because they're pulling that energy into itself, so we can't see what's happened to it. All right, it's after they release that we see the light come out from it. All right, now this light that we see, we do say that they release a photon of light, which is what we sometimes call a packet of light. It is our quantum model where we describe light as both a wave and a particle. So we actually basically say it's this particle of light that's being released. Yes, it's not matter or anything like that, but it's in this kind of packet of light that comes out with that amount of energy. Okay? So again, when you're absorbing energy, you'll be increasing the energy level of the electron. When you release energy, you are lowering the energy level, and light is getting released. Because again, that energy has to go off somewhere. It has to go into some other form. All right? So again, that electron energy is seen as visible light. Based on which energy levels they're dropping from, you can get different colors of light, is what we're looking at there. All right, sorry, skip the page. So with that, we got electrons, again, will release the energy in the form of visible light. What I was trying to say with the transition between levels is electrons can jump. They don't need to jump just to the next energy level up. So going back to like this page, we can have electrons jumping from 1 to 2, or they can jump all the way from 1 to 3. And then they can fall back down from 3 to 2. That will give you one color of light. Or they could fall all the way down from 3 to 1, and that would be another color of light. So it's possible that they could release multiple different colors. Even 2 to 1 can be different. Okay? These differences in energy levels are not all identical. They actually, like we should be, while we draw them as like concentric circles, the spacing between them is much more, I don't want to call it, it's not random, but it's not consistent. I don't want to say there's not a clear pattern with it other than we know the amount between certain energy levels. So the flame test that you used, it's used to identify metal ions. It's used for metal ions because, again, those metallic ions, we will learn a lot more. They don't hold those electrons as well. They're a little bit more freely moving. And so we can easily kind of determine more easily determine what color certain flames make with metals versus non-metals, which like to hold on to those electrons a bit more, and they don't move as easily through those energy levels. And again, that's just telling you how we did it. Again, energy is released. We see the color of light when the energy is released and when they're dropping down to a lower energy level. Applications of it, fireworks, neon signs, the northern and southern lights are a sign of that, using the magnetic field to excite those electrons. I mean, there's lots of different actual purposes that we've gotten with that. So again, one last time, electrons gain energy from going from a ground state. The ground state is their lowest energy state to an excited state. When they release energy, they go from an excited to a lower energy state, and they will release that in the form of light. Perfect. Thank you.